Without further ado, please allow me to welcome the very distinguished and renowned speaker of tonight, Dhruv Rastogi. Dhruv has an impressive experience in data science of over 12 years enriching products and services to drive tangible commercial impact. At IKS Health as VP and Head of Data Science, he's focused on building cutting-edge AI products for all lines of businesses and functions to drive operational and delivery excellence. In his previous role, he was Vice President Big Data and Advanced Analytics at Vodafone Idea. He has strong experience working with cross-functional stakeholders and scaling data science teams, strategizing, designing, and deploying solutions across the value spectrum. Dhruv has also appeared as a lead speaker in key AI conferences in the industry and academics community. A very warm welcome to you, Dhruv. We are thrilled to have you here with us tonight. Handing the session over to you.
Yeah, thanks for the kind introduction, Shama. I hope I'm well audible and the screen is also shared.
Yes, I'm just sharing the screen. Meanwhile, audience, here is a question for you. So we want to know more about you, and hence please quickly take this poll, which describes your current role in your organization, and let us know where you come from. Dhruv, are you able to see my screen?
Yes, very much.
Okay, I think we are good to start. And the poll results are, a lot of them are from business analyst background and software and IT professionals and data science.
Awesome. Okay, so let's get started. So when it comes to building AI products, a lot of unique aspects arrive, right? It depends on data, it depends on models, it depends on the accuracy of those models. And hence, there is a higher element of risk and uncertainty, right? So understanding, it's important, while building AI products, to understand everything it takes to build a typical tech product, right? But at the same time, work with the uncertain timelines and also outcomes, right? In addition, there is also incremental work required in educating senior leadership on how AI works and how it really impacts the various timelines, the budget and performance of the particular business we are operating in, right? This is Dhruv Rastogi. Welcome to the session of building AI products with me. And today we'll be talking about 4 key aspects in building AI products, right? The first one, we'll talk about some of the key technology concepts, right? And the idea here is to walk everyone through some of the top concepts which are required to understand how AI products work. Second is, we'll talk about some of the important elements in building business strategy with AI, right? So today we have a lot of tools, we have a lot of companies who are building AI, but how do we really build or use AI for building a business strategy, right? The third important element is, how do we build products, right? Or how does product development becomes more challenging when various elements of AI and data science pour into it, right? And last but not the least, we'll also talk about a very important element, which is about data management, data strategy, and related facets, right? So with that, we'll move to the next slide. Okay, so first of all, the basic definition, right? So what does AI really mean, right? And to understand that, we'll simply talk about, what is the difference between traditional algorithms and artificial intelligence, right? So traditional algorithms are nothing but a well-defined set of procedures and rules, right? Which tells machines what to do. For example, a calculator is an algorithm, right? It doesn't, right? So everything about what a calculator should do is very well coded, very clearly coded for the calculator. But when it comes to artificial intelligence, It's essentially telling a computer not just what to do, but telling a computer how to learn, right? For example, this is very similar to, let's say, how babies learn, right? So we don't tell a baby that, hey, this is, if something has feature A, feature B, feature C, feature D, then it becomes a dog or it becomes a cat, right? What we tell babies is, hey, this is a cat, and then the baby learns on its own, right? So similarly, artificial intelligence comes with its set of cognitive abilities, right? Abilities to read, ability to understand, ability to hear, right? And ability to comprehend things, and ability to do tasks like humans take tasks, right? So that's the difference between traditional algorithms and algorithms or artificial intelligence based systems. To the next slide. Okay, now there are some important concepts in artificial intelligence, and many of these terms are sort of used interchangeably in the industry, right? So sometimes I think people confuse, hey, what is machine learning? What is deep learning? What is artificial intelligence, right? So to be very clear with the definitions, right? So deep artificial intelligence, we've just defined what artificial intelligence is, right? But coming to how that differs from machine learning is, machine learning actually is a subset of AI techniques, right? And it comprises a lot of statistical methods, it comprises of a lot of techniques, right? Which enables machines to improve with a lot of experience and experimentation, right? So that's what machine learning is, right? So it's actually a sub-component of the entire AI canvas, right? And in addition, what does deep learning really mean, right? So deep learning, again, is a subset of machine learning techniques in a way, right? And the way it does predictions, or the way it learns, is actually in the form of multi-layer neural networks, right? So we'll come to what neural networks are in some time, but it's again a way to predict, it's again a way to understand patterns, but it uses multi-layered neural networks, right? Now, some of the questions which people many a times ask is, when do I use ML? When do I use DL, right? And then there are many factors which we can use to figure that out, which we can use to understand that, right? So in machine learning systems, the interpretability is much higher compared to deep learning systems, right? Another advantage of machine learning systems is that the time required to build ML-based systems is much lesser compared to those of deep learning-based systems, right? Similarly, the cost efficiency, right? It's easier, not just lesser time, but it's also more cost efficient to build machine learning based systems. And but at the same time, deep learning has a couple of advantages, right? One is the accuracy many a times happens to be much, much higher, right? And the other advantage is deep learning systems many a times don't require domain expertise, right? They can work as black box systems, and they don't require domain expertise, right? Coming to one additional factor, a graph that you see on the slide, right? So when does the accuracy of deep learning system really starts improving, right? It starts improving after we have a critical volume of data in place, right? So if the data volume is limited, typically machine learning and deep learning systems work more or less in the same way, right? At operating at the same accuracy levels. But as the volume of data keeps going up, the deep learning system starts outperforming at a higher pace compared to typical machine learning systems. Move to the next slide. So we won't delve into the details of this, but as we just said, what do these neural networks based systems look like, right? So many of you might think, hey, this looks like the neurons in my brain, right? And that's typically how neural networks started quite a few years back, right? So all of these networks you see here on the screen are different kinds of neural networks, right? So they typically have an input layer, then they have some hidden layers, and then they have an output layer. They have various concepts like activation function, forward propagation, backward propagation, and other concepts like convolutional neural networks, recurrent neural networks, and so on, right? So what I mean by these is, there are dozens of neural network architectures, right? And different kinds of architectures are used for different purposes. For example, if we were to work with images, then a different kind of architecture would be used. If we were to work with time series, or if we were to work with language, right, then different kinds of neural networks and graphs would be used, right? And I think that's what typically data scientists or machine learning engineers have expertise in. Move to the next slide. So here is a quick quiz for everyone, right? So here are a few questions, and you can take like 30 to 40 seconds and try to answer as many as possible. The question is, if you have a given use case, would you use ML or would you use DL? So I'll pause here for 30 seconds to 1 minute, and you can enter your answers in the chat box.
Audience, please go ahead and post your comments in the chat window, and you can name them with the numericals 1 to 6.
So you can give in your answers as 1.ml or 2.dl or 3. Something else. It'll be easier for us to read. Okay, so we'll move to the solution slide. Okay, superb. So the first question was, a photo sharing company with millions of user images wants to train a model to label what those images are, right? And when it comes to images, the amount of data is huge, right? There are so many pixels of data, and there's a certain way the images are organized, right? So in such cases, typically deep learning techniques are very popularly used. The second one is, a bank wants to build AI that approves or denies an individual for a mortgage, right? Now, in such decisions, a lot of explainability is required, right? The regulations require banks or financial institutions to explain why a particular loan was approved or disapproved. And that's the reason why machine learning systems are more popular in this domain. The third one is, a student who wants to work on an AI project but has a short deadline to build and train the model, right? The key elements are short deadline, right? And since the time is short, we don't want to spend a lot of time, right? And that's the reason why ML systems are better, because of the speed. The fourth one is, again, about images, right? So there is a question on X-rays and what kind of techniques should radiologists use. And that's where deep learning again triumphs. The fifth one, again, is about images, right? It's a law enforcement agency, and they want to use facial recognition for searching, right? So you might have seen such applications many a times in movies or TV shows, right? So that's where deep learning systems, typically convolutional neural networks and many other advanced such networks are used, right? And last but not the least, it's about building chatbots or conversational AI, right? And this is again one domain in which there is a lot of language being exchanged, right? And that's why we have conversational AI that's used. I mean, and we have deep learning that's very frequently used for conversational AI.
There is a question here relevant to what you're saying before we move on. This is from Vidushi. Why DL is used for images?
Okay. See, the way images are constructed and built, right? The amount of data that's presented there, and the way that they can be used by deep learning systems, by neural network systems, especially by convolutional neural network systems, right? It's far, far superior compared to how a machine learning system would work, right? If you imagine the number of input data points, right, which come from an image, they can be of the order of thousands and thousands and thousands, right? And that's one area where deep learning systems perform much, much better. Okay, now coming to machine learning algorithms, right? So we spoke a bit about deep learning algorithms. We spoke a little about when and why would a ML technique be used compared to a DL technique, right? Now we'll talk about what are the different kinds of machine learning techniques, right? So typically there are three types of ML techniques, right? One is what we call as supervised, the other is what we call as unsupervised, and the last one is reinforcement techniques, right? So supervised techniques are those where all the input records have a output label, right? Where you know that, hey, if I have these input features, this will translate into a particular output feature, right? For example, you get the information about an email and you figure out from past data whether it was a spam or a ham, right? Or you have stock market data and then you figure out that, hey, the next price, the label for the next movement, is it up or down, right? So in all such cases, supervised machine learning techniques are used, where you have some input features and you have a well-defined label. Then we move to unsupervised learning techniques, and this is where we want to find out patterns, right? We want to do a lot of pattern mining. We want to figure out which of the records are similar to each other and can be grouped in the same category, right? And that's where unsupervised machine learning techniques are used, right? For example, if you want to group records or cluster record basis the features which are there, right? Many a times in fraud detection as well, we want to figure out, hey, do we have certain transactions which are looking similar to each other, right? And because some of those transactions are fraudulent, there is a high propensity that even other transactions are also fraudulent, right? And reinforcement technique is the third one, and that's very popular for specific kinds of applications, right? Where the machine isn't like really trained in a way like in supervised or unsupervised techniques, but it is it is learning by making mistakes, right? So every time it makes a mistake, it gets penalized. Every time it performs the right action, right, it gets rewarded, right? And these applications are very popular in areas like robotics or chess or self-driving cars, right? So that's where reinforcement techniques are very popular, right? Move to the next slide. So this, again, we won't go into the slides, but we were talking about various kinds of machine learning techniques, right? And on this screen you might see a dozen machine learning techniques, and I think in totality there could be 2 to 3 dozen popular machine learning techniques which are used by machine learning practitioners or data scientists, right? So some of the techniques are very popular and are used more often than others, but there are quite a few which are there, right? And again, it's not just about the technique, but it's also about using the right technique at the right place with the right set of parameters, right? And that's where each of those techniques have to be trained on the past data as well, right? So what I'm trying to say is that, hey, there could be two people, both of them using the same technique, but one of them using it correctly and the other one of them using it incorrectly, maybe because the algorithm isn't tuned, or maybe because the data on which it has been trained is not up to the mark, is of poor quality. Move to the next slide. Okay, so here are some questions again to keep you thinking. So let's think about each of these points and figure out, hey, is this a supervised learning problem or is this the unsupervised learning problem? So we'll again have about 30 seconds to 1 minute, and you can pour in your answers in the chat box.
I encourage the audience to keep the session interactive and engaging. So please drop in your comments in the chat window.
Yeah, I'll walk through some of these myself, and you can put in your answers. There's nothing right or wrong about it. Just feel free to put in your answers here. The first one is predicting future trends in price, right? So we just spoke about this in the previous slide. Okay, object detection, right? So if you have an image, okay, we have quite a few answers. Excellent, Vadushi. Thank you. Do we have any more answers from the audience?
In the Q&A window as well.
Okay. Okay. Got it. Excellent. We've got answers from Karan as well. Okay. Thank you, Karan. Thank you, Vidushi. We'll move to the solutions. Predicting future trends in price is a supervised learning problem, right? Because you can look at past data and the past data will tell you that, hey, these are the features that led to a price uptick or a price downtick, Object detection, right, is typically a supervised learning technique because you had past images and past data, and that data was used to train. Right, grouping customer segments, right, can again be a supervised learning technique. Fraud detection is typically a unsupervised learning technique, right? There are supervised variants of this as well, but these days, from what we understand, most of the fraud detection systems have moved to unsupervised, largely because the way frauds are conducted, right, keeps on varying very, very fast, right? It's very, very rapid, the way frauds are conducted. So the way they were conducted 1 year back is not how they are conducted today, right? And that's the reason if we use past data to predict the future, it will not work because the past data would have the patterns of the older frauds, right? Spam detection, right? It's typically supervised learning technique, and prediction of financial metrics, again, just like the first one, is again a supervised learning technique, right? In some of these, I think few of us can debate that, hey, I could have done this using unsupervised as well, and the answer is yes, we can. The way we've written the answers here is, what is currently, from we understand in the industry, is more popular, right? But some of these can have unsupervised versions as well. We'll move to the next slide. So coming to the canvas of technologies out there, right? So data science, especially the way it's implemented in products, is very, very varied, right? So there are a whole bunch of tools and techniques and technologies that are used in machine learning, right? There are a bunch of tools and techniques used in business intelligence, right? Again, for web development, for building applications on products. The plethora of languages is also very varied, right? So there are some winners which are very popular today, right? But there is serious competition from others also in this pack. Coming to DevOps, right? This is again one very critical, important area which we call as ML ops, right? And that essentially helps us to make systems scalable, to have faster delivery timelines, right? And this is again one very key area. And last and not the least is data engineering, right? And there are again a whole bunch of techniques, databases, tools, workflow systems, etc., which are important here. Move to the next slide. Okay, so enough about technology concepts, right? We spoke about AI, ML, DL, we spoke about supervised, unsupervised, reinforcement learning. We looked at quite a few examples in each of those categories, right? Now we'll move to how do we develop business strategy with AI, right? What are the most important things to keep in mind while we build business strategy with AI? To the next slide. Okay, so the first important thing is, how can AI help a business, right? And as we speak today, AI is helping businesses across industries in many different ways, right? One is insight generation, right? How do I get more actionable insights from the data that I already have, right? And it's not, the world has moved from just getting descriptive numbers and analyzing things uh, on a retrospective basis. The world has moved from there to, what do I do with the data that I have, right? How do I make these insights more actionable, right? Is this insight, can this insight help me to take a meaningful decision that can help me in a business outcome, right? That's where insight generation is very important. The second is around operational efficiencies, right? So many companies, across many functions, whether it's around improving productivity, improving quality, it's about enhancing the efficiencies in supply chain, or it's about getting the most optimal way HR policies work or HR systems work, right? How do we improve hiring? How do we reduce attrition? There are many ways in which we can improve the way we operate, right? Adding innovation to an existing product, right? There are many ways in which existing products can be made more innovative, right? For example, a simple dashboard can be made more innovative by having a conversational interface to it, right? So, you don't just get a static piece of report, but you can actually talk to a database, right? Which we call as conversational AI, right? And last and not the least is developing a new product, right? So While the first three were focusing on, hey, what do I do with my existing business? How do I improve my existing business? How do I add innovation to my product? But the last one is about, hey, can I build something radically new with AI, right? And there are many examples in the world today across various industries where people have built absolutely new products leveraging AI technologies like speech to text or language technologies or audio technologies or other pattern mining methods. Move to the next slide, Shuma. Okay, so here is another quiz, short quiz, and let's think about what people think about each of these use cases, right? First is predicting maintenance of machines in a factory, right? Do you think this is an operational efficiency? Is this insight generation? Is it innovation to an existing product, or is it a new product? Okay, any answers? Okay, we've got some in the Q&A section. Excellent, Karan. Let's move to the next one, which is trend analysis in order to get an in-depth understanding of the consumer. Okay, we'll move to the next one. Scheduling optimization, right? For it could be a doctor, it could be a lawyer, it could be anyone, right? How do we do scheduling optimization? Okay, you can put in your answers. Fourth is Google Assistant. What kind of a system do you think that is, right? Is it a new product, or is it an operational efficiency? Is it insight generation? And last and not the least, using AI for recruitment. Okay, let's move to the answers. The first one, as we said, is operational efficiencies, right? Predicting the maintenance of machines in a factory. The second is insight generation, like knowing more and more about a consumer. Scheduling optimization, right? That's innovation to an existing product. And Google Assistant is a new product, right? Something like this did not exist earlier. And using AI for recruitment is innovation to an existing product, right? So, even today we have a lot of recruitment-based products, right, which help in workflow, which help in filtering candidates, which help in putting the pipelines together. But if you use AI, let's say for better matches, for smart hiring, then that becomes innovation to the existing product. Okay, we'll move to the next slide. Okay, so how do these products influence a customer's workflow, right? One, as we said, is it makes humans more productive, right? So just imagine today, right? If you want to search for anything on our phone, if you want to search for a particular image, we can simply search it. It's very well organized. It's organized with respect to places and faces and everything, right? So it has made us more productive. Similarly, it also helps when it's difficult to write down the rules, right? Or what we call as sometimes greenfield products, right? So many a times it's not easy to write down rules, right? For example, high frequency trading or inventory allocation or predicting attrition or self-driving cars or predicting drugs, right? Or I mean, in AI drug discovery. In many of these places, we need AI to even figure out the patterns, right? It's very difficult for a human to figure out the underlying patterns. And that's where a lot of techniques like neural networks, etc., come into the play. Move to the next slide. Okay, next one. Okay, so with a basic understanding of how and where can AI be used to develop business strategy, we'll move to how do we develop products and what are the challenges in building products with data science. Okay, so first of all, we need to understand that, hey, what is the role of AI and ML in the product, right? So people have been building products for so many years, right? So how does AI and ML fit into this workflow, right? So we look at it from two dimensions, right? From a feature to core dimension and from a standalone black box to a end-to-end solution. dimension, right? So if we think of certain products, let's say a speech to text product, right? Or a product which helps in image recognition or object detection or language enhancement, right? So these are typically standalone black box products, right? They don't need typically anything else, right? And they are the core as well, right? But for example, if we think of something else like a self-driving car or a surveillance drone, right? So these are solutions in which AI is at the core, right? And without that, the product doesn't really have any meaning, right? For example, there is no meaning of a self-driving car if it cannot see objects, detect objects around, and take the right decisions, right? Another dimension which you see in 4 is products, areas in which AI acts as a feature, right? And systems, for example, if we look at a OTT system like Amazon Prime or Netflix or Hotstar or others, right? They all of them have a recommendation system, right? But a recommendation is a feature in these products, right? So these products can work standalone as well, right? Essentially a repository of content, right? But how recommendations help us is that they help improve the user experience, right? They help in users being on the platform for a longer time. But the core system even works even if there weren't a recommendation system. I hope this makes sense. We'll move to the next slide. Okay, another important aspect is what we call as role of humans in the loop, right? So many a times humans are required to make AI usable, right? So AI isn't a magic box. It's not a magic pill. Most of the AI systems that we use today, whether it is speech to text or anything in language, anything in images, even otherwise, right? All of them have been built with a lot of uh, input, with a lot of support, with a lot of intelligence by humans themselves, right? And how do humans help, right? Or how do people help in building AI systems? One is they help in handling the edge cases, right? Many a times a machine can't really figure out, hey, what should I do in such a scenario, right? And it is then that a human would say, hey, this is right and this is not, right? And the reason why machines typically don't work in such cases is because such cases did not have enough past training data, right? And if they didn't have enough past training data to handle a case, they won't be trained well to handle that case. The second one is building the training data sets themselves, right? So if machines have to learn, somebody has to build a training data set for it, right? And that's where humans come in. That human helps. Humans, people, programmers, database folks, they all help in building these data sets. Generating heuristics, that's another important aspect, and quantifying the sample accuracy, right? So for example, even when machines are trained, right, someone has to say that, hey, the machine is currently operating at a particular accuracy level, right? And it is there that for all these samples, the accuracy has to be estimated by a person, right? And so these are the 3 or 4 reasons why humans are needed to make AI usable, right? And there are many business models around it, and some of the largest organizations, use a lot of people to make AI usable or build AI which is of high accuracy. Move to the next slide. Okay, now some of the important aspects are not just limited to data science, but even otherwise. And why this is very important is because as we speak today, right, even though things have matured a lot, but a large proportion of or a significant proportion of data science or AI related products are not able to reach production, right? So they do very well in the lab environment. They do well when it's about building a POC, but many a times, they don't perform well when it is running things at scale, right? Or they don't perform well as they were expected to, right? And that's the reason why certain hygiene tasks are pretty important. One is defining the purpose and the mission statement and the core deliverables before anything, right? It's very easy to jump on a data set and do something funky with it, right? But the most important thing is, hey, what am I really trying to solve with this data set? First, define the problem statement and then move to solving the problem. Second is the data pipelines before models. Again, is a very, very common challenge, which I think many people in the data community face, right? Uh, Build a model on a, on a sample data set, right? But when it comes to having this running in production at scale with well-oiled data pipelines, with good exception handling, etc., that becomes a challenge, right? And that's where data engineering and ML ops become very, very critical. Testing the infrastructure and best practices before models is very similar to what I just mentioned in the earlier point. Culture and communication before models. This again in AI becomes very important, and which is to keep all the stakeholders aligned, right? Many a times, certain business stakeholders or certain users many a times think that, hey, oh, I have data, put this into a AI system, and hey, everything is done. But that's not how AI models are developed, right? There is a process, there is uncertainty, there are challenges in building this. It could be data quality, it could be quality of the algorithms, it could be the latency that is acceptable, right? It is the SLAs which have to be met, right? And that's the reason why at every step in building the process, in building the model, it's important to have the right culture and the right communication with all the stakeholders. And last and not the least is data analysis and engineering before building the models, right? So get the data right, understand the data well, and only then start building the models. Move to the next slide. Okay, so I already spoke about this in the previous slide, but typically tech products have three things, right? The technology, the user experience, and the business context. But what becomes more challenging in product development with AI is the key element of data, right? So while you already have the challenges of technology, of UX, of business, all of them working together for the business goal, an important area which is to be worked on is the data availability, is the data quality, right? Is ensuring that the data pipeline, that the foundation is in place. Move to the next slide. Okay, now here is something which is very exciting, very interesting, right? And what makes AI companies, AI startups, AI products very, very exciting, right? And this essentially, if you compare the left-hand side with the right-hand side, it talks about that. And this effect is what we call as the AI flywheel effect, right? And this again is something which is very critical for, let's say, social media platforms or networking platforms, right? But let's look at this in more detail. So if you look at a typical tech product, right, it has a life cycle. It gets introduced, it grows, it matures, and gradually, as the world changes, as businesses change, as the user expectations change, things decline. But it's very different in the case of an AI product. In an AI product, the more data, the more users come on the platform, the more data they generate. The more data they generate, the smarter the algorithms become. The smarter the algorithms become, the better the product becomes, right? And hence more users come in. For example, a product might start with 1,000 users, but with those 1,000 users, the system gets more data. The more data, the better algorithms become. The better the algorithms, the better the product, right? It could be improving the user experience. It could be understanding how the customer journeys are. It could be understanding how the recommendation systems are. It could be about understanding customer um, attrition on the platform, right? So the more data that gets consumed, the smarter the algorithms become, the smarter the pricing systems become, the smarter the product design becomes, right? And many of the large tech products today have benefited immensely by this AI flywheel effect. We'll move to the next slide. Okay, so here are a few pointers. We don't have enough time, but I'll briefly walk through it. Product ideation techniques, right? So there are many product ideation techniques. There are wireframes, there is WAS, and there are many others that are based on user experience design. So it's important to choose the right ideation technique. MVP and MVD, I think a lot of us on this call might already be aware. What I would like to talk about is about Agile, Scrum, and Kanban, right? So when it comes to developing products, Kanban is typically data products, right? Kanban is typically more preferred than Scrum. And if you just search online, you'll find like 100 articles where people will talk about why Kanban is better in AI products, in data science products, than what Scrum is. We'll move to the next slide. Okay, here is another important challenge which every product manager, in fact, every AI product manager or a data product manager faces, right? Should I build or should I buy, right? If you'll go to the market, you'll figure out a lot of startups, a lot of companies, a lot of innovative companies who would have worked on similar problems that we would have, right? Or which we are looking to work on. So how do you figure out whether you should go with enterprise AI or you should build in-house, right? So while every company figures this out in their own way, but one key principle to remember this or to ensure which is being complied with is if it's something which is core to the business, right, then it better be built in-house, right? Don't outsource anything that is core to the business, right? Similarly, if something is not core to the business, right, it's an ancillary item which is not core to the business, it's okay to outsource it, right, or to use the help from a startup or a tech product company, right? I think one of the important examples which come in here is well documented one is of a large uh, supermarket chain, right? And in the early 2000s, what the supermarket chain did was they did not have their own in-house e-commerce platform, right? They relied on one of the large e-commerce players to run their entire uh, online sales, right? But in a few years, they realized that online sales is core business, right? About maybe 20, 30 years back, online sales weren't big. But today, online sales are very important for every supermarket chain. And hence, outsourcing it or taking help from an e-commerce vendor wasn't really the right strategy. So with that, we'll move to the next slide. Uh, okay, I think we'll skip this for now. We are running short on time. We'll move to the last one, which is the data management and related strategies. And Shema, we'll move to the one important slide, which is on data collection techniques. Then, which is the next slide.
Okay.
We'll spend a couple of minutes. The one after this. Okay. Yes, one, right? So, we spoke enough about data and how important data is, but many times people ask, hey, where do I get all the data from, right? Or how are people in the industry getting all the data which they need to build these AI products, right? So there are many techniques, right? And depending on which industry we come from or what is the stage of the company or what is the stage of growth the company is in, there are many data collection methods that can be used, right? One is leveraging open data, right? Second is crowdsourcing labeled data, right? Third is getting data from the users themselves, right? Which we spoke of, let's say, in the AI flywheel effect, right? So if users are on a platform and the users themselves start sharing data from their interaction with the product, right? Company data. So many companies have rich data, right? It could be data of the users, it could be data of, let's say, some of the vendors they are working with. It could be data of the past sales, of the past products that have been launched, the life cycle of users, the life cycle of products, and they can use this data to make better decisions. And last and not the least is purchasing data itself, right? And this becomes very important, let's say, when you want to venture into a new area, right, where you have not worked in the past, right? Or you're, let's say, launching a new company and you don't know, how do I make data-driven decisions, right? So there are many vendors out there which can help in purchasing data, right? So they already have a repository of many a times anonymized data, right, which others can use, right? And today there are data marketplaces as well, which are getting very popular, right, where people can buy and sell data according to their use. So we'll move to the next slide and we'll talk about the comparison between all of these techniques. So open data, yes, it's very useful. Why? Because it's easily accessible. Many a times it's free as well, right? It can be reused, it can be redistributed. But what is the challenge? The challenge is it's not tailor-made, right? It is not very, very specific for a particular business task or a particular problem we are working with, right? Because these are generic data sets available on the web. So we figure out, right? These are the pros, these are the cons. Hey, will this work for me or not? Next slide. So these are some of the open data sources. There are 100 more on the web. So next time you are working on a data product, try to figure out online if this helps. Right. Move to the next slide. Okay, crowdsourcing labeled data, right? And this again is big business. This again is something that's very important, right? And this is where a lot of companies have even gone ahead and acquired other companies, right? This is where some companies have separate divisions within their groups themselves, right? For example, some of the OTT platforms have teams which they call as data annotation teams, right? And what those teams do is, hey, they watch a movie or they listen to a song and write down the various characteristics or the various labels or the various tags for that song or that movie, right? That's where human in the loop really comes into place, right? Or if we even talk about self-driving cars, right? Those for a car to learn, a human, or say not a human, in fact, hundreds of people have to look at millions of images, right, and label these images. Hey, this is what this is a pothole, or this is a tree, or this is an old man, or this is a young woman, right? That's how the machine would learning from the images vis-a-vis the labels. You move to the next slide. Again, new features, right? And especially collecting data from users. So all of us who are on any social media platform, right? Every time we interact with the platform, we give information about ourselves to the platform, and the platform uses that information to make our experience better, and second, also many a times for targeted ads as well, right? For targeted content as well, right? So anytime we press like on something or we comment on something, it tells the platform that, hey, this is a user, or there could be other lookalike users like this user who are interested in content like this, or who are interested in product like this, or hey, this is what these people are more connected with, right? And this is where things like cross-selling, upselling, recommendation systems, or loyalty programs come into play. To the next slide. Company-owned data, right? So this is the most superior quality data, right? And it helps a lot in operational efficiencies, right? And why I call it superior is because it is very, very tailored, very, very specific for the outcomes a company is looking to achieve. The challenge many a times it could be very limited, right? In the sense, this is specifically for a particular company itself, right? Some of the examples which you see on the screen is, it could be the user behavior data. I think there's a bit of misalignment with the pros and cons. Anyways, so there is email activity, there is interaction from the customers who are users or customers of a particular company or a product, right? The more we understand about them, the better we can serve them. Next slide. Okay, we'll close the session with one last quiz, and we'll have about 30 seconds. You can read through these and then suggest that in this kind of a business scenario or this problem area, what is the right data collection strategy? Okay, we'll move to the solutions. Okay, the first one is a medium-sized business with voice recorded tech support calls wants to build a voice authorization system, but needs to annotate what each voice recording is about, right? And since it's about annotation, crowdsourcing the label data is a very useful technique, right? Similarly, a social media website wants AI to scan their feeds for offensive material, but they do not have enough offensive images to train a model on, right? And this is a great case where acquisition or purchasing data would help, right? Similarly, let's say a bank wants to leverage AI to help their customers make good financial decisions, but they don't have the data about customers' risk preferences. So in such cases, banks either explicitly or implicitly uh, have or use the user's data to figure out uh, what the appetite or what the risk appetite of a customer is. Hey, should this customer be recommended a debt product or an equity product or something else, right? So we'll move to the next slide. Yeah, I think this is something many of us might already be aware of, but this is about how do we organize data, right? So it's about data warehouse and data lakes, and this calls for another session. So we won't go into the details here, but it's important for product managers to understand how data at a top level is really organized. Next slide. Um, okay, next slide.
Dhruv, that's it, I believe.
Okay, fantastic. Though I think with this we come to the close of today's talk, and broadly, I really want to give a brief overview, right, about what we did. We spoke about what the various key technology concepts are. We spoke about how products can be developed or enhanced with AI. We spoke about data strategy. How do we collect data, right? And how do we monetize data in organizations? And we also spoke about how business strategy can be developed, or what are the various techniques or different ways in which businesses can leverage AI and data science.
Okay, thank you so much, Dhruv, for that brilliant and insightful session. And the audience, here's your chance to ask your questions live. So what you can do is you can raise your hand and I can unmute you, and you can have a live discussion with Dhruv. Alternatively, you can put your questions in the Q&A window, and we'll take them as it comes. There is one question from Vidushi here, Dhruv. Any recommendations on resources to learn basics of data science for a PM aspirant?
Well, there are quite a few sources, right? But yes, I mean, your question is more relevant for product managers, right? So, see, I think as a product manager, there are quite a few courses that are available, and largely what's required there is to get a more business understanding of data science. So you may not be like a hands-on expert in choosing the right algorithms or fine-tuning algorithms, but understanding the core concepts across the board, knowing something about data engineering, data collection, different kinds of algorithms, designing the UI, UX, etc. All those would be key concepts. So there are quite a few courses. I'm sure. I think Shama can add more if she knows more about any of those, if IPL offers those.
Most definitely, Dhruv will communicate that. There is another question from Madhuri. How does AI ML can help to access the structured data in best possible way? Example like user base accessing a video library.
I didn't really get the question.
Madhuri, would you want to come online and ask your
Yeah,
question? You can raise your hand and I can unmute you. We have a lot of positive comments as well in the chat and Q&A window. This session was brilliant.
Thank you. Glad to know, this was helpful.
Okay, I guess Madhuri does not want to come online. So do you want to take that or should we move on?
Okay, I mean, I'll try to answer I don't know if this really answers Madhuri's question, but as far as structured data, accessing structured data is concerned, a lot of supervised learning techniques or recommendation systems help building those, right? So that's where I think recommendation systems are a good way to get the best out of large video libraries.
Okay.
Yeah.
Great, audience. Giving you a few more seconds to ask your questions. Okay. Madhuri, you'll have to raise your hand for me to unmute you.
Okay, I think she's having a bit of problem with her mic.
So Shalini has raised her hand. Dhruv, and can we have Shalini here?
Yeah. Hi, Dhruv. This is Shalini. Just have a question on the data sources. So let's say if you are a company and you want to utilize the company data, but that itself is not sufficient, can you combine two sources, even though they're coming from two different backgrounds? Like,
yes, absolutely, and a lot of companies do that a lot of times, right?
Because internal company data, my personal experience that sometimes yes, it's relevant, but it's very sketchy. Like a lot of gaps and all are there, so a lot of time is required to kind of just put it in a process, like in a format, so that some analysis can be done.
Absolutely, and a lot of companies do this many a times, right? So while they might have their own data sets, but they want to enrich it with more data sources, right? It's about looking internally and looking externally, right? So for example, if you have consumers, you have data about those consumers in your own databases, but that's very, very limited about, let's say, the interaction they're having with your product, right? Or with your service. But what if you want to get a more 360-degree view of the customers,
right?
Or you want to understand how lookalike customers are behaving, right? So that you can recommend similar actions for those customers, right? And that's where companies end up purchasing more data sets, right? Or they even collaborate with other companies or other groups so that they get richer profiles about their customers.
Sure. Thank you.
I hope that helps.
Yeah, sure. Thank you.
Okay, awesome.
Okay, in view of the time constraints, Dhruv will have to end the session here. And audience, thank you so much for all the questions. But you can always ping us with more questions and we'll get the answers from Dhruv. So give me a minute here so I can check for any last questions. Okay. Thank you, Dhruv, for hosting this brilliant session, and we have enjoyed having you with us. It's been a complete pleasure. Please accept this certificate of appreciation from the Institute. And if you scan the QR code on the screen, it'll take you to a dedicated Hall of Fame page that we have created for you, which will hold the recording of this session.
Okay, thank you so much, Shama, and thanks all the audience. I hope this the last 60 minutes of your time were
absolutely. I'm sure the audience had a lot to learn from this session.
Yeah.
Thank you.
Okay, all the best. Take care and good night.
Good night. And audience, please scan the QR code and let us know how the session was. And if you want any changes or any recommendations, please go on and share your review with us.
Okay, all the best, everyone. Take care. See you.
Thank you. Good night.
Good night.
Thank you for joining in, folks. It was great interacting with you all. See you all tomorrow for the day 2 of the Data Literacy Month 2022. With that note, I end tonight's session. Happy learning and stay skilled. Have a great night.